We will start some question answer practice, and we will follow a particular chapter wise question answer practice. Now first we start with the kinematics of one dimension, means motion in one dimension. Write down the first question. A wheel of radius 1 meter rolls forward half a revolution on a horizontal ground. Full stop. The magnitude of the displacement of the point, of the wheel initially in contact with the ground is option A 2 pi meter, option B √2 meter, option C root over of pi square plus 4 meter, option D pi meter.
Option D, sir.
Option?
Option D.
Why? 25% each is probable.
It should be 2.
It should be 2. Okay. Any other? Each option is 25% probable. Answer 2. কত নম্বর?
It is half revolution, then diameter into displacement.
Okay. There is no such option. What is the answer? First, draw the diagram that half revolution is completed by the wheel, then the initial contact point and then final contact point goes top. Then what is the displacement of this contact point? Means this distance you have to, this length you have to calculate. Option C is the correct one. Root over of pi square plus 4. How? See. Check. This one is the wheel. Okay. So this is the horizontal ground. After half revolution, the wheel comes here. According to the drawing, wheel gets bigger after one revolution. Okay. So what happens in this case? Initial contact point. This was the initial contact point. Okay. Now this contact point after half revolution goes here. Okay. So you have to calculate this distance to calculate the displacement of that contact point. Now drop a perpendicular from here. Since it is half revolution, so in a complete revolution, what will be the linear distance covered? Equal to its circumference, that is 2 pi r. So in half revolution, the linear distance covered is pi r. So this one is pi r. This one is diameter, that is 2r. So this is the displacement S. So S square should be equal to pi square r square plus 4r square. Okay. So S equal to root over of pi square plus 4 into radius. Now radius is given 1 meter. So answer is root over of pi square plus 4 meter. This is the correct answer. So whenever there is this type of a question, first calculate that if there is a complete revolution of the wheel, it crosses a horizontal distance equal to its circumference, that is 2 pi r. Since it is half revolution, So linear distance covered is half of the circumference, that is pi r. So this pi r is this distance, this height is 2r, because this point goes to the top after the half revolution, because after complete revolution this point again comes to the bottom in contact with the ground. So this is at the top. So now form the right angle triangle and calculate the hypotenuse, that is the displacement. Okay. Is it clear to everyone? Okay.
Sir,
One more problem per se. Okay, see, this is a wheel. Now this is the contact point. Now it rotates. If it rotates and completes one revolution, then again this point will come to the ground. But it says that it is completing half revolution. Half revolution means this point goes to the top. In one complete revolution, the linear distance moved forward by the wheel is equal to the length of its circumference. So in half revolution, how much it will move? Half, that is pi r. Now this height is 2r because that is diameter. So what is the displacement of this point when half revolution completed? This hypotenuse. So calculate hypotenuse. Okay. Now, next problem. A body traveling along a straight line. Mark it as question number 5, not 2, because I am giving it from a book. So I will pick some questions and discuss in the class. Remaining problem I will give you for solving. So that's why the number I want to maintain. Question number 5. A body traveling along a straight line traverses 1/3 of the total distance. With a velocity 4 meter per second. A body traveling along a straight line traverses 1/3 of the total distance. With a velocity 4 meter per second. Okay. The remaining part of the distance was covered with a velocity 2 meter per second for half the time, and with velocity 6 meter per second for the other half of time. The remaining part of the distance was covered with a velocity 2 meter per second for half the time, and with velocity 6 meter per second for the other half of time. Okay. The average velocity over the whole time of motion is Option A 5 meter per second, option B 4 meter per second, option C 4.5 meter per second, option D 3.5 meter per second. অপশনগুলো 5 মিটার পার সেকেন্ড, 4 মিটার পার সেকেন্ড, 4.5 মিটার পার সেকেন্ড, 3.5 মিটার পার সেকেন্ড। 5, 4, 4.5, 3.5. First, calculate the average speed for the second part of the problem. Second part is divided into two parts. To equal time, it is traveling for 2 meter per second with velocity 2 meter per second and 6 meter per second. So for this part, first calculate the average velocity. It is the average velocity over equal time. Equal time means simply you can add and divide by 2. Because when distance traveled are equal, then average speed calculated by 2 v1 v2 by v1 plus v2. But when time intervals are equal, average speed is calculated by v1 plus v2 by 2. So first calculate the average speed for the second part. Because two time intervals are given equal. First time interval, in half of the time interval, it moves with 2 meter per second. Next half, it moves with 6 meter per second. So what is the average? 4. 2 plus 6 by 2. Okay. So second part of the problem, it is traveling with average speed 2 meter per second. Now 4 meter per second. Average speed is 4 meter per second for the second part of the problem. Now for the first part, with which speed it is moving? 4. So if it is moving previously 4, now again 4 average, so what is the total average? 4. If it is moving first part with a certain part with 4, then next part is also moved with 4, means you can consider that the velocity is not at all changing. So total average will become 4 itself. So the answer is 4 meter per second. Okay. So don't need to calculate 2 V1 V2 by V1 plus V2 anymore, because first part, if you consider 1/3 of the distance, next part again it is moving with same average speed. So first part and second part are moving now with same speed. When you calculate the average for the second part, then total entire average will become only 4. Okay. If you try to apply that formula of total distance by total time, you can calculate, it will again come out to be 4. Question number 9. An object moves starting from rest. An object moves, comma, starting from rest through a resistive medium, such that its acceleration is related to velocity as a equal to 3 minus 2v. A equal to means small a, acceleration equal to 3 minus 2v, where v is the instantaneous velocity. Then option A, the terminal velocity is 1.5 unit. The terminal velocity is 3 unit. C, the slope of A versus V graph is not constant. The slope of A versus V graph is not constant. Initial acceleration is 2 unit. Initial acceleration is 2 unit. See, we have to use this equation twice. S equal to ut plus half at square. Okay. So first part, it is starting with initial velocity 0, and in the 10 second it covers a certain distance that is mentioned as x. So we can consider x equal to half a into 10 square. This is my first equation. For the second part, if you again use that y equal to some initial velocity plus half a into 10 square, then first you have to calculate that initial velocity which the particle acquires after first 10 seconds. Because this is a total journey. It is divided into 2 time intervals, 10 second, 10 second. Throughout it is moving with a constant acceleration. So while it covers first 10 second in after first 10 second it acquires some initial velocity. So for the second 10 second, when you are calculating, you cannot put u equal to 0 if you calculate it for the 10 second only. So we will do a different thing. This is the first 10 second, this is the next 10 second, but here we have to calculate the velocity of final velocity at the first 10 second, which will be treated as the initial velocity for the next 10 second, but we will not calculate that. Rather we will calculate the entire interval together, such that I can again consider this here the initial velocity to be 0. Then what is the total distance covered? X plus y. So I will consider x plus y together. Then I can put again this equation u equal to 0, and it will be half a into 20 square, because total time taken is 10 plus 10 now. So either calculate velocity at this point, but to calculation of the velocity at that point can be eliminated, can be bypassed if you consider the entire interval together. Okay, so this is a better method not to calculate the velocity at this point. So this is your second equation. Now we have to eliminate a from this. So I will divide equation 2 with equation by equation 1 simply. So it will be x plus y by x, that is equal to half a will cancel, it is 20 square means 400 by 100. So it will be x plus y equal to 4x, so y equal to 3x. That is the answer. Half a will be cancelled when you divide these two equations. So the first thing is that you have to calculate two different intervals separately. For that you have to calculate the velocity at after first 10 second, which will be treated as the initial velocity for the later 10 second. Then you can write the equation. Otherwise, bypass this velocity calculation by considering the total interval together, and then you have to eliminate a from both the equations such that you can find the relation between y and x. That is the problem. Okay. Question number 13. A car starts from rest. A car starts from rest. Question number 13. Comma, moves with an acceleration a, small a, moves with an acceleration small a, and then retards at a constant rate b, and then retards at a constant rate b for some time to come to rest. For some time to come to rest. If total time taken is t, then find the maximum velocity achieved by the car. Then find the maximum velocity achieved by the car. Option A ABT by A plus B. Option A, ABT by A plus B. Option A into B into T, ABT divided by A plus B. Option B, A squared T by A plus B. Option C, AT by A plus B. Option D, A square B square T by A plus B. A square B square T by A plus B. It is a very common question. Option. First option is ABT by A plus B. Option B is A squared T by A plus B. Option C, AT by A plus B. Option D, A square B squared T by A plus B. What is the correct option? You said correct option first. Who said that option at the beginning? Except Rakibul, one said the correct option. Someone said option A. Who?
They say that repeat the
option. It is very common question. Which one is most important concept you learn in physics? Most important concept that you learn in physics. The first concept that you learn in hydrostatics, that is the most important concept for you right now. Pressure, which you are feeling right now. Because previously when I discuss the kinematics and mechanics topics, many of the students started some problem, try some problem, something on their own. But Today I feel that due to immense pressure, all the mechanics is gone. See, first draw the velocity time graph. First, the particle is moving with constant acceleration. So graph will be like this. Suppose it is moving with constant acceleration. We are drawing the velocity time graph. Okay. Now, then after reaching a certain velocity, the particle now moves with retardation until comes to rest. So it goes down. Okay. And acceleration and retardation are not with the same rate. So that's why I draw two different slope for acceleration and retardation. Okay. Now, from this, drop a perpendicular. Now let us consider the time t1 is spent for acceleration and time t2 is spent for retardation. The total time is given t, and I consider among the between the total time t1 time is spent for acceleration, t2 time is spent for retardation. Then I can consider here velocity is 0. This velocity increases to a maximum value v, that is the maximum value, and again it comes to 0, then the particle stops. Then for the first part of the journey, I can use the equation v equal to u plus at, that is final velocity v equal to initial velocity 0 plus acceleration a into time t1. and we can write T1 equal to V by A. Okay, T1 equal to V by A. Now, for the second part of the journey, what is the final velocity? 0. What is initial velocity? Retardation B into T2. Retardation means minus, that's why. So it will become T2 equal to V by B. Okay. So for first part, acceleration, initial velocity 0, final V. So final velocity equal to initial velocity plus acceleration into time. So we got T1 equal to V by A. Similarly, in the second part, this is initial, this is final. So final velocity equal to initial velocity. Since it is retardation, this is minus B into T2. So we got T2 equal to V by B. Now, the total time taken is given in the problem, that is small t. So we can write T equal to T1 plus T2 and put the values of T1, T2 here to find the value of V. That is the answer. So T will be equal to V by A plus V by B. So take V common and solve. Find the expression for V from this. Okay. So it will come ABT by A plus B. Okay. So option A is correct. Question number 19. 19. A ball is dropped from a high-rise platform. A ball is dropped from a high-rise platform at t equal to 0. At t equal to 0. Full stop. After 6 seconds, another ball is thrown downwards from the same platform. Another ball is thrown downward from the same platform with speed v, with speed u. The two balls meet after 18 seconds. The two balls meet after 18 seconds. What is the value of u? Option A, 74 meter per second. What is the value of u? Option A, 74 meter per second. Option B, 55 meter per second. Option C, 40 meter per second. Option D, 60 meter per second. Options are 74, 55, 40, 60. And it is considered that platform is sufficiently high such that the balls will not reach the ground within 18 seconds. See, in the problem it is said that a ball is dropped from a high-rise platform at t equal to 0, starting from rest. After 6 seconds, another ball is thrown downward from the same platform. The two balls meet at t equal to 18 seconds. Means the first ball is falling through 18 seconds, the second ball is falling through 12 seconds. Okay, so this is the platform, and if they meet at this point, then first ball crosses this height in time 18 seconds. So we can consider h equal to half g into 18 square. H equal to half g into 18 square. The next ball crosses the same height in 12 seconds, but it is thrown down with a certain velocity. So we consider u into 12 plus half into g into 12 square. Okay, u into 12 plus half g into 12 square, because we use the equation s equal to ut plus half at square. Now equal to u into 12 plus half g into 12 square. Okay, so we can write half g common into 18 square minus 12 square, that is equal to 12u. So from this find the value of u. g কত ইউজ করেছো? g
70.
ঠিক আছে, you can put g equal to 10. Calculate the value of u from this equation. So it is coming 10 by 2 u is coming 75 meter per second. Option মধ্যে 74 আছে, they are using 9.8. If you consider 9.8, then it will be 74, and if you consider g equal to 10, it will be 75, but the value of g is not mentioned. Okay, so option 1 is correct. If you consider 9.8, then it will come 74. If you consider 10, it will be 75. Okay, next question. 21. when a ball is thrown up vertically, when a ball is thrown up vertically with velocity v naught, with velocity v naught, it reaches a maximum height of h. It reaches a maximum height of h. If one wishes to triple the maximum height, if one wishes to triple the maximum height, comma, then the ball should be thrown with velocity. Then the ball should be thrown with velocity. Option A, root 3 v naught. Option B, 3 v naught. Option C, 9 v naught. Option D, 3 by 2 v naught. Option A, root 3 v naught. Option B, 3 v naught. Option C, 9 v naught. Option D, 3 by 2 v naught. Means 3 v naught by 2. Don't write v naught in the denominator. V naught is always in the numerator. Option A. Correct. এত সোজা কোশ্চেন তো। See, you can consider first that the ball is reaching the maximum height where velocity will be 0. Its velocity is v naught square, and when it is thrown with a velocity, it is reaching a height of h, then it will be 2gh. So this is your first equation. Okay, now you want to increase the maximum height up to 3h, then you have to throw it with a different velocity. Let us consider the final velocity is again 0. You have to throw it with certain velocity v minus 2g into 3h. This is my second equation. Okay, so from these two equations you can write v square by v naught square. This is equal to 2g into 3h divided by 2gh. Okay, because from this equation you can write v square equal to 2g into 3h, and from first equation you can write v naught square equal to 2gh. Then divide these two. Then this 2g will cancel, h will cancel, it will be 3. So take a square root on both sides. So v will be equal to root 3 into v naught. That is the answer. Option A. Just an application of the third equation of kinematics, v square equal to u square plus 2as. Twice you have to use that equation to solve this problem. Otherwise you can also use the conservation of mechanical energy to solve this problem, because when it is thrown it has only kinetic energy, and when it reaches the topmost point it has only potential energy. So from that you can equate the energy conservation equation twice and solve the problem, because from energy conservation you will get the same equation actually. Okay. Write down question number 30. The position x of a particle with respect to time, the position x of a particle with respect to time t along x-axis is given by x equal to 9t square minus t cube, 9t square minus t cube, where x is in meter and t is in second. What will be the position of this particle? What will be the position of this particle when it achieves maximum speed along positive x direction? Maximum speed along positive x direction. It is given that x equal to 9t square minus t cube. So first you have to calculate the velocity, instantaneous velocity, by taking the derivative. So it will be t square, its derivative will be 2t, so it will be 18t minus 3t square. Now you have to take the derivative once again to find the acceleration. Acceleration a equal to 18 minus 6t. Okay, now velocity is maximum when acceleration will be 0, because first derivative, velocity's derivative is acceleration, so first derivative 0 means you will find the maxima minima. So from that you can consider set a equal to 0, which will give you 18 minus 6t equal to 0, means acceleration is 0 at 3 seconds. So velocity will be maximum at 3 seconds. So at that moment, what is the position of the particle on the x-axis? So just put this value of t here to find the x at 3 seconds. So that will become 9 into 3 square minus 3 cube. Okay, 3 cube. So it will be 3 square, means 9 into 9, 81 minus 27, that is 54 meter.